The apparatus you're looking at is called the Clevenger Apparatus. It was invented in 1928 by the American scientist Joseph Franklin Clevenger. At the time, he was working in agricultural research, where scientists were studying the essential oil content of medicinal and aromatic plants. The distillation methods available back then made it difficult to accurately measure how much essential oil could be extracted from a particular plant. To solve this problem, Joseph Clevenger designed this clever piece of laboratory equipment. So, let's see how it works. There are two main types of Clevenger apparatus, and the design depends on whether you're extracting a light essential oil or a heavy essential oil. The apparatus you see here is designed for light essential oils. Light essential oils have a density lower than water, so they naturally float on the surface. That's why this particular design is ideal for extracting them. One of the key features of a light oil Clevenger apparatus is that its return tube begins from the bottom. You'll also notice the graduated markings along the collection tube. These markings allow us to measure exactly how many milliliters of essential oil have been collected during the extraction. Now let's look at how the entire system works. Water inside the boiling flask is heated until it turns into steam. As the steam rises, it carries the plant's volatile compounds, including the essential oil. The vapor then enters the condenser, where it is cooled and converted back into liquid. This condensed liquid flows into the graduated collection tube. Inside this tube, the hydrosol collects at the bottom, while the essential oil floats on top because it is less dense than water. As more condensed liquid enters the tube, the hydrosol level gradually rises. Once the liquid reaches the height of the return tube, only the hydrosol flows back into the boiling flask. The essential oil remains trapped above the return point because it continues floating on the surface. This creates a continuous recycling process. The hydrosol keeps returning to the flask, while the essential oil steadily accumulates in the collection tube. Because of this continuous circulation, there's no need to worry about the boiling flask running out of water during the extraction. With a conventional distillation setup, the water level inside the flask gradually decreases, making it difficult to know whether all of the essential oil has been extracted. The Clevenger apparatus solves that problem. We simply continue the distillation until no more essential oil is collected. Once the oil level stops increasing, we turn off the heat and allow the apparatus to cool. At that point, the essential oil remains floating above the hydrosol. We carefully open the stopcock and drain the hydrosol first. As soon as the essential oil reaches the outlet, we close the stopcock immediately. Finally, we measure the collected essential oil using the graduated markings and transfer it into a storage bottle. And that's the complete working principle of the Clevenger apparatus. Now, let's use it to extract eucalyptus essential oil,